Welcome back. Today we're going to be taking a look at part 2 of our absolute value lesson. In the previous section, we looked at the definition of absolute value and we did some computations. In this part of the lesson, we're going to be taking a look at absolute value functions. And specifically, we're going to be looking at linear functions being turned into absolute value functions. So if you remember from our definition from the last section, we looked at the absolute value of a number being the distance from the origin. So if I have -4 and I'm looking at the absolute value of -4, I'm looking at how far the -4 is from 0 or from the origin, and that distance is 4. So the absolute value of -4 is +4. The absolute value of a positive number stays positive. So our simplified version was that if we have a number and we're taking the absolute value, we should finish with a positive number. So the absolute value of -3 is +3. So now we're going to look at an absolute value function. So an absolute value function can be defined as any function in the form y equals a times the absolute value of b times x minus c plus d. Now, in 20-1, we're just looking at how to graph absolute value functions. When you go further into math, likely into 30-1, you'll be looking at transformations, and that's when those b's and c's and d's are going to have a little bit more relevance. Now, a, b, is c, and d are any real numbers, and a cannot be 0. If a was 0 and we multiply that by our absolute value, it would disappear because 0 times anything is 0, and we would just be left with our constant, meaning we'd have a constant function. Now, a simple example for an absolute value function is y equals the absolute value of x. Now, the absolute value function y equals absolute value of x is defined as a piecewise function. Now, we're going to talk about piecewise functions in much more detail in a later lesson, but right now it's important that you know an absolute value function is an example of a piecewise function. So y equals absolute value of x has to be broken into two sections because we have to consider what happens to the graph when x is positive and what does the graph look like when x is negative. So if x is positive, that means x is greater than or equal to 0. We can see what happens by using an example. So 6 is an example of a number that's greater than or equal to 0. It's a positive number. And when we take the absolute value of 6, we have +6. So notice a +6 stays a +6. If x is negative, so we have negative x, that means x is less than 0. An example might be -6. Well, when we take the absolute value of -6, we have +6. So our positive values stay positive, our negative values become positive. All right, so let's take a look at a table of values. So for here, we're given a table of values, and we're given the values for x and f of x, and we're asked to find the new values for the absolute value of f of x. And so if I have -3 and 6, my new point would be -3, and it would stay +6. So 6 stays 6. -2 comma 4 becomes -2 comma 4. -1 comma 2 is -1 comma 2. 0 and 0 stays 0. 1, -2 now becomes 1 and +2. 2 and -4 becomes 2 and +4. 3 and -6 becomes 3 and +6. And 4 and -8 becomes 4 and +8. And so if you take a look here, all of our positive values have stayed positive. So 6 stays 6, 4 stays 4. But as soon as we get into those negative y values, all of our negative y values have now become positives. So all of our parts of the graph that would be in the negatives for y have now moved into the positives for y. So let's take a look at an example here. Now we're being asked to graph y equals the absolute value of 2x minus 4. Now there's two different ways we can do this. One is with a table of values, and one is using that concept we just talked about positives staying positive and negatives becoming positive. So let's start off with our table of values here. We're given some values for x, so -2, -1, and so on. We're going to substitute them in to get our y values. So showing our work here, I would have 2 times -2 minus 4, and when that's all absolute valued, we're going to have a positive value. So 2 times -2 is -4, minus 4 is -8, and the absolute value of -8 is +8. Then for -1, we have 2 times -1 is -2 minus 4 becomes -6. The absolute value of -6 is +6. For 0, we have -4, and the absolute value of -4 is +4. For 1, we have 2 minus 4 is negative 2. Absolute value becomes positive 2. 2 times 2 is 4 minus 4 is 0. And the absolute value of 0 stays 0. Then we have 2 times 3. So 2 times 3 is 6 minus 4 is a positive 2, meaning it will stay positive. And we'll continue on here. For 2 times 4 minus 4 becomes 8 minus 4, which is 4. And the absolute value of 4 is 4. And the last one, we have 2 times 5 minus 4 becomes 10 minus 4, which is 6. And the absolute value of 6 is 6. Now we're going to take those points and plot our graph. So negative 2 comma 8, negative 1 comma 6, 0 comma 4, 1 comma 2, 2 comma 0, 3 is at 2, 4, 4, and 5 comma 6. Now to sketch this graph, we're going to pull out a straight edge or a ruler and we'll sketch that graph. Now, if you notice as we're sketching that graph, well, I can draw a V without lifting my pencil. Essentially, I had to turn my ruler, so I was graphing that function in 2 different sections, and that divider point was happening right at my x-intercept. So let's take a look at some properties of this graph. First of all, we're asked for the domain. Well, the domain of this function is x is the element of reals, so x can be any number in the real number system. We look at range. All of our y values are greater than or equal to 0. So this point is included, so we make sure there is an equal to sign. Y is greater than or equal to 0, and y is the element of reals. Now for our x-intercept, that's when y equals 0, so our x-intercept is happening at 2 comma 0, and our y-intercept is happening at 0 comma 4. Taking a little look further here, the x-intercept of the original linear function is the blank of the corresponding absolute value function. So the x-intercept of the original function, if I were to graph that original function of y equals 2x minus 4, that graph would go up in this direction and it would cross right at 2 comma 0. Well, that has now become the vertex of our new function, of our absolute value function. So the x-intercept of the original function becomes the vertex of the corresponding absolute value function. And because those 2 points are the same on both graphs, they're called invariant points. So we talked about invariant points with reciprocal functions, and now we're also dealing with invariant points when we have absolute value functions. So just as a refresher, that's when our points are the same on both the original graph and the new graph. All right, so there's another method that we can look at when it comes to graphing, and that's using that concept of positive values staying positive and negative y values becoming positive. So we're going to start off by graphing the original equation y equals 2x minus 4. So we're going to plot our point at negative 4, and then our slope is up to right 1, so 2 over 1, up to right 1, and so on. And so we're going to pull out our ruler here to sketch that function. It's really important that everything lines up so that you can find the points you need without having to use a table of values all the time. All right, make sure that that graph extends through the entire grid, and then we draw our arrows. Now, once we have that graph, we're going to take a look at our positive and our negative y values. So all of these points above the x-axis are positive, so they're going to stay positive. It's all of our values that are below the x-axis that are going to become positive. So we have a point here at 1 comma negative 2. That will now become 1 comma 2. We have a point at negative 4, so 0 comma 4. We have a point at negative 1 comma 6. And then we have a point at -2 and -8. And then all the rest are off our grid, so we'll stop there. So notice that all of our positives stay positive, all of our negatives are going to be reflected in the x-axis. We now use our ruler to sketch that graph. And it might be helpful to label our graphs as well. So we have here y equals 2x minus 4, that's our original function. And then we have y equals the absolute value of 2x minus 4 as our new function. Now, when we're taking a look at this graph, sometimes what helps is to actually cover up the part that was below the x-axis, and notice now what was below has now moved above. Other people sometimes, if they're needing a visual, can actually take a piece of paper and put that x-axis right on their fold line, and when they fold the paper, they'll see that what was below the x-axis has now flipped up. All right, and then we've sketched our graph. So these are the two methods that we can use for sketching absolute value functions. We're just getting started with linears. In the next lesson, we're going to be looking at quadratics. If you have any questions, please ask. Have a great day, and we'll see you soon.